This video is for lesson 33-2 about three-dimensional shapes called cylinders and cones. Learning goals are to discover the properties and cross-sections of a cylinder and the properties and cross-sections for a cone. First, let's discuss cylinder. A cylinder is the set of all points in space that are a given distance from a line known as its axis line. The bases of a cylinder are parallel to each other. If the axis of the cylinder is perpendicular to the bases, then the cylinder is a right cylinder. If the axis is at an angle to the bases, then it's an oblique cylinder. This drawing shows an illusion on flat paper of the three-dimensional object called a cylinder. To create the illusion, you draw the bottom and top as ovals, but in reality they're not really ovals. What shape are the bases of a cylinder? The bases of a cylinder are circles. One of the vocab words from yesterday was cross-section. If you slice through a cylinder parallel to the bases, the cross-sections are also circles. Now the first thing we're asked to do is to label the axis. The axis of a cylinder runs from the center of one circular base to the center of the other circular base. It's this dashed line. So here's the axis of that cylinder. The radius of a cylinder is the distance from the center of one of the bases out to the edge. That's this dashed line. The height of the cylinder is the distance between the bases. In this drawing, that axis line also represents the height of the cylinder. But the height of the cylinder is also the distance along this edge. So for question 1, we've labeled the different parts of the cylinder. Number 3, let's draw an oblique cylinder. The bases of all cylinders are circles, but when you draw it on paper, you actually draw ovals to create an illusion of 3 dimensions. To make it oblique, I'm not going to draw straight down with my edges. Instead, I'm going to draw them at an angle. And then round off the bottom. If you like, you can use a dashed line to represent the back edge of that circular bottom. Here is an oblique cylinder. Next, let's discuss the three-dimensional object called a cone. Like a cylinder, a cone has a circular base. Unlike a cylinder, there's only one base because the cone stretches up to a point called the vertex of the cone. Here are some drawings of cones. 2 of the cones are right cones, and 2 of the cones are oblique cones. Can you figure out which is which? The first 2 are right cones, and the last 2 are the oblique cones. Like a cylinder, the circular base of a cone has a radius, the distance from the center out to the edge. And like a cylinder, a cone has a height, which is the distance from the base up to the vertex. Notice that in a right cone, the radius and height are perpendicular to each other. That creates a right triangle shape, which is useful because if we ever need to know the length of the diagonal side of a cone, we could use the Pythagorean theorem. Slide down just a little bit on the page and look at the 3 drawings. Here we have a cone. Here we're showing that we're slicing through the cone at that spot right there, and then removing the top of the cone. When you look down from the top at the shape created, what is the cross-section of a cone? It's a circle. Move to the check your understanding, number 9. Describe the shape of the cross-sections that are perpendicular to the bases of a right cylinder. Earlier we said that the cross-sections parallel to the bases are circles, but what if you slice the cylinder end to end? What shape would you create? The shape would be a rectangle. Let's summarize this lesson. We discussed two three-dimensional objects, the cylinder and the cone. Both have circular bases, but a cylinder has two circle bases and a cone only has one. The cone stretches to a sharp point, like the pyramid does. We also discussed cross sections. If you cut through these shapes parallel to the bases, the cross sections are circles. But if you cut through at a different angle to the bases, the cross sections will not be circles.